In this lecture, we're going to learn about the STD set associative container. This is a container that automatically orders things as you put them in. So for example, if we insert data in this order in our STD set container, what we will end up with in memory is going to be something like this. The data is going to be automatically ordered. And this kind of behavior imposes a condition on the pieces of data we can store in our STD set container. We must have a way to decide which element comes in front of another, or in other words, we must have a way to order our elements. And this will require the types we put in to have a less than operator that the STD set container is going to use to order things from smallest to greatest. So here are a few facts about STD set. It is a container that orders its elements. This is something you should remember. It doesn't matter which order you insert elements in, STD set will order them automatically. This is going to impose on the types that we put in to have a less than operator that's going to be used by the STD set container to order things. Because elements are ordered, it is going to be super easy to find elements. And this is going to be the same thing we do to find words in regular dictionaries. This is going to go very fast. It is possible to customize how elements are ordered. By implementing our less than operator, we can either put this in explicitly or use a three-way comparison operator that the compiler is going to use to generate our own less than operator. We have seen how this works when we learned about the three-way comparison operator. It is also possible to specify a callback that is going to be used to order things. We can do this by using a function pointer, a functor, or even a direct lambda function that we can put in place. Another thing worth remembering is that STD set doesn't allow duplicate elements. If you try and put in another copy of another element that is already in, STD set is just going to ignore you. It's not going to add it to the collection because duplicates are not supported. And to decide that an element is a duplicate, the STD set container is going to do something like this by using your less than operator. It is going to test and see if x is not less than y and y is not less than x. And this is going to be true only if the two elements are equal. And if they happen to be equal, the second copy is not going to be added in. This is something you should remember and keep in mind. Okay, so to use STD set, you need to include the set header. This is going to give us access to our container. And we can look at a few examples of how we can work with this bad boy. So we can create an STD set just like this. This is going to be storing integers. We can put them in a random order like this, but the container is going to order them automatically. So if we happen to print our collection using our print collection method here, we're going to see that things are going to be ordered. It is also possible to store in custom types. So for example, we can put in book types that we set up in our C++ program. We can create book objects on the fly and put them in our collection, and they are going to be ordered using the less than operator that we have in our books collection here. And this is really cool. If we print them out, we're going to see that they are going to show up in order. Okay, here is how our book class might look like. It is a regular class with two member variables. One is an integer, which is going to represent the year. The other is an STD string, which is going to represent the title for the book. And we have a less than operator that we implement explicitly like this. And this is going to work really well. So the compiler is going to use this operator to order books. And a book is going to be greater than another if its year happens to be greater than another book's year. This is the setup we have here. We also have an output stream operator to make it really easy to print book objects, and this is really cool. Now, with the STD set container, we have a bunch of iterators we can use. We can use forward iterators. We see begin and end right here. But we can also use reverse iterators. We see R begin and R end here. And we can also print our books in reverse order. You can see that right here. I am just trying to give you as many examples as I can to really drive these things home. We have a few capacity methods we can play with. We can get the size of our collection. We can test and see if it isn't empty. We can get the max size. This is going to be really cool if you need these things in your C++ application. We have a bunch of modifiers. For example, we can clear our collection just like we did for other containers. And if we clear, we're going to see that our collection is now going to show up empty if we print it out here. We can also use the insert method. And the insert method is going to return an STD pair object containing the result about our insert operation. So here we can print our collection, and we're going to see that we're going to print 11, 12, 13, 14, 15 here. But if we try and insert 14 again, this is going to fail because we already have a 14 inside here because we don't support duplicates in STD sets. Now, after we attempt to insert a 14, we're going to try and print our collection again, and we're going to see that the second 14 wasn't put in. The insert here has failed. It is possible to capture the result of our insert in an STD pair object. And that's what we do here. We are deducing the type for this little guy. So this is going to store the result of our addition in the second position. And the actual piece of data that was inserted is going to show up in the first position of our STD pair object. Now, this is going to be an STD pair object, which is going to contain an iterator to what we just added in the first position. So this is going to be an iterator we can use to get the data that we just added in. And the second position is going to contain a true or false value, meaning that the insertion was either successful or it was a failure. If we go down and print, we're going to see that result first is going to be an iterator. We can dereference it if the addition was successful, and we can get whether the insertion was successful or a failure in the second position here. This is going to be either true or false. With this, we can do a check like this to know whether our insertion was good. If in the second position we have a true, our insertion was good, we can get the data and dereference our iterator. If it was a failure, we're going to fall down here and we can print an error message saying that our insertion was a failure and that it was a duplicate. You can do something like this. Hopefully you can see the usefulness of STD pairs when you start working with associative containers like STD set. This is really cool. We also have an in place method, which is going to build an object in place and put them in our collection. When we call our in place method, we don't need to specify an iterator. This is really the same case as insert because the container is going to order things how it sees fit using the less than operator. So we can call our in place and we can see if the addition was successful. If it is successful, we're going to fall right here and say that this was successful. If we failed, we will hit the second block here and we will print our message here for the world to see. Now, it is also possible to erase elements, and before we erase an element, we want to find the iterator where it is. We can use the std find method as we have seen before. If we find it, we're going to say that we found it. If we don't find it, we're going to print a message. And after we find the element, we're going to erase it. And if we print the collection, we're going to see that the element is gone. This is going to work as you expect. And we have seen this a lot in previous lectures. It is also possible to swap element. This is going to work exactly the same as we saw for other containers. And the last thing I want you to see is that it is possible to customize how STD set is going to order your elements. One way we have seen we could do that was by putting in our own less than operator, but we can even pass callback functions that are going to be used by STD set to decide which element is greater than another. One way we can do this is use the default like we have been doing all along, and the compiler is going to use a built-in functor, which is std-less, to decide which element is greater than another. It is possible to specify the functor explicitly as we do on this line here. So we can say std set and specify a functor which is going to be used to decide which element is less than another. And our things are going to be ordered exactly like we did on top here by default. The beauty of this is that we can specify any kind of functor really. We can put in a built-in functor. For example, we can use std greater. This is going to order elements from the greatest to the smallest. And when we hit Visual Studio Code in a minute, you're going to see this. We can even pass our own functor, and this is going to work really well. When we hit Visual Studio Code, we're going to set up this comparator, which is going to be a functor, and it is going to order our elements exactly following the logic we have in our functor here. It is possible to also use the function pointer as a callback, but the syntax to do that is a little bit weird. This is what we have here. We say std set, we specify the type of data we have in our set, and then we specify the signature for the function pointer that is going to act as our callback here. It is going to return ball, and it is going to take two integers n, and it is going to compare them. And then after we have this setup, we specify our variable name for our set, and then we pass our function pointer as a parameter within these two pair of parentheses. You should remember this syntax. Once we use function pointers like we do here, we don't have the luxury to initialize in place using braced initialization, but we have the option to insert our data using the syntax here. This is going to work really well. We can even use lambda functions, and again, the syntax to do that is a little bit weird. You say std set like this, you specify the type that is going to be stored in your set, and then you say std function and specify the signature for the lambda function that is going to act as your callback here. It is going to return a ball. It is going to take two parameters in, and then we specify our variable name right here. And within this pair of parentheses, we're going to specify our lambda function, which is going to act as our callback. The lambda function is going to take two parameters, left and right, which are of int type, and it is going to compare them and return a Boolean value as we have in our signature here, and this is going to work. Once we have this set up, we can insert our elements, and then we can use a range-based for loop to see the order that the compiler has put our elements in, and we can confirm that the callbacks that we passed in this craziness we have on top here are taking effect. And we're going to try this out in a minute when we hit Visual Studio Code. Now that we know these things, we're going to go to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is std set. We will grab the template files as always and put them in place. And we will open this up in Visual Studio Code by dragging and dropping here. This is going to give us our main CPP file, so we can clean it up a little bit. And we're going to include our set header, so let's do that. The first thing I am going to do is put in a few things we're going to need. We're going to need our book class to see that we can store custom types in std set containers. We have our book class, which is going to have a less than operator that is going to be used by the compiler to order things. And then we have an output stream operator, which is going to allow us to print these things on the terminal. Down below, we have a print collection function, which is going to be using our forward iterators. So we grab our beginning iterator and use it in our loop here, and we're going to keep incrementing, moving to the next element. This is something you already know by now. Now, we are going to go down in the main function and set up an std set object. This is going to be storing integer types, and we specify that using our template argument here, and we're going to put in data. You see that the data wasn't ordered when we put that in our collection. We have 11, 16, 2, so this is really in random order, but you're going to see that if we print our collection, it is going to be already ordered because std set does that. std set is going to order your elements as you put those in, and it is going to use the less than operator that your type provides. Let's go down and pass this through our compiler. Let's use GCC for the task. The build is going to be good, so let's clear, not clear here. We're going to bring up a terminal window, and then we're going to clear properly and run Rooster. Once we do that, you're going to see that the data is ordered, and this is really cool. You have 2, 6, 11, 15, 16, 9, 12, and this is really cool. Our std set is going to order the data, even if we didn't put the data in our container in order. This is what we have right here, and I want you to see this. Now, it is also possible to set up an std set of custom types. In this case, we're going to set up an std set of book objects, and we're going to put in a bunch of books. So we're going to put in one that was published in 1734. We're going to give it a name. We're going to put in one for 1930 and another one for 1995. And we're going to see that these books are going to be ordered by using the less than operator that we have in our book class. If we go on top, we're going to see that we have decided which book is greater than another by using the year member variable. So if the year is greater, the book is going to be greater than another book. This is the setup we have here. Let's try and print our collection. You see that we didn't put them in order. You see that 1734, 1930, and 1995, these things are ordered. But for example, we can try and put 2000 first here. Let's put that first. Why not? And then we're going to see the order these books are going to be printed in. They are going to be using our less than operator here to decide which book is less than another. We can pass this through our compiler. Let's do this. We're going to use GCC as always. The build is going to be good. And if we clear and run Rooster, we're going to see that we will build a collection in place. This is what we have done before right here, but down below we have our books printed out, and we see that the first one is 1930, even if we had the book for 2000 put in first. So the compiler is going to use our less than operator to decide which book comes first, and the book that is less than other books is going to come first. You see we have one for 1930, we have another one for 1995, and we have another one for 2000. This is the setup we have here. Now, if you go in and change your less than operator, you're going to see that books are going to be ordered from greatest to smallest. Let's change this to not be less than and say greater than. You can see that right here on line 13 in our editor. If we go in and build again, you're going to be in for a surprise. Our compiler is going to use the less than operator, and it is going to order things from 2000 all the way to 1930. You see that they are in reverse order because we reversed the logic for our less than operator. This is some kind of flexibility you have to change how things are ordered for your type. Let's turn this back to be less than because it was really confusing when we made this be a greater than comparison when the operator is a less than comparison. We're going to try and build again, and we're going to see that things are going to be ordered from smallest to greatest. If we run our program, this is what we have right here. With STD set, we have all kinds of crazy iterators we can use. We have forward iterators, we can use them with numbers here. We have reverse iterators, we can use them with numbers here again. So if we do that, we will see our data printed out in reverse order. And we can print our book in reverse order. This is something we are just putting here to let you know about these iterators for STD set. Let's pass this through our compiler. I don't think there is much to explain on this by now. The build is good, so we can clear and run Rooster. And with our iterators, if we print with forward iterators, the data is going to be ordered. If we print using reverse iterators, the data is going to be reversed. You see that here. We can even use reverse iterators to reverse our collection of books. And you're going to see that the one from 2000 is coming first because things are now printed out in reverse order by using our reverse iterators. This is really cool. You should keep this in mind. We also have a bunch of methods we can use to query for the capacity of our STD set collection. So we have a size method, we have an empty method we can use to ask and see if our collection is empty. We have a max size method, which is really going to do the same thing we already know. It is going to tell us the maximum number of elements we can put in. If we pass this through our compiler, the build is going to be good, and we can clear and run Rooster. We will see that the max size is a really huge number. The set is not empty, so this is going to give us a 0 or a false. And if we try to get the size, we're going to get a 6 because we have 6 elements inside. This is no surprise by now. We can look at a few modifiers we have with STD set. For example, we can clear the collection and make it empty. We're going to print the elements, then we're going to clear, then we're going to print it again to see that it has become empty. And we can prove this or confirm this using the empty method here. And this is going to give us our confirmation. So let's pass this through our compiler. The build is going to be good as you see right here. So if we clear and run Rooster, we will see that the collection is going to have data. Then we're going to clear, and if we print it out again, we're going to see that it is going to become empty, and our empty method is going to return a true that we see right here. We can also insert data in our STD set collection. And here is a simple example of something we can do. We have our numbers collection, which contains this data here. We're going to print it out. Then we're going to try and insert a 14 again. Now, you already know that STD set doesn't support duplicates. This is going to silently fail. And if we print our collection after inserting, we're going to see that the 14 wasn't inserted. And we can prove this by running our program through the compiler. We're going to get a binary if the build is good, and we can run our binary. So let's run Rooster. We will see that before the insertion, this is the data we have. And after the insertion, this is the data. You see that we don't have two 14s inside. So the insertion we did right here is a failure because STD set doesn't support duplicates. But it is possible to actually grab the result of our insert method here and use that to check and see if the insertion was successful or if it was a failure. Here we will set up an example. We're going to grab the result, and you're going to see that the result is going to be an STD pair. The key is going to be an iterator to the element that we added, and the value is going to be a Boolean, which is going to represent whether the insertion was a success or a failure. You can see this here through the return type deduction we are doing with auto here. This is really cool. So one thing we can do is dereference the first iterator, and that's going to give us the element that we just added in the collection. And if we print the second data member, we're going to get a Boolean, which is going to represent whether the insertion was a success or a failure. Let's put a separator here to be able to follow this on the console. We can go down here and say stdc out and use a bunch of hyphens. This is going to do. And if we build and run, we have 3 set of columns. We don't want this, we want 2. We're going to pass this through our compiler. The build is going to be good, so we can clear and run Rooster. You're going to see that after we insert the 20 here, first is going to contain 20. If we dereference the iterator we get back from this insertion, we're going to get a 20. This is what was added. And you see that the second data member contains a true, meaning that the insertion was a success. Now, let's try and do an insertion which is going to be a failure. And we can do that by commenting out the line here and trying to insert a 14 again, and we're going to see what we get. Now, I want you to guess and tell me what the iterator that is going to be returned in the first position of this STD pair is going to be pointing at. Try to guess, and then we're going to try and run our application and prove that. So we can pass this through our compiler again. The build is going to be good, so let's clear and run Rooster. We're going to see that first, it's going to contain the element that we were attempting to insert in our collection. But second is going to contain false, meaning that the insertion was a failure because 14 was already contained in our collection here. So we can't add it again because STD set doesn't support duplicates. We can use this to our advantage and check and see if the insertion was a success or a failure. So we can go down here and do that. And we're going to put a separator in front of this to have this easy to follow in our terminal output window. We're going to put in a bunch of hyphens. This is going to do. And we're going to test and see if the second data member contains a true. If that's the case, the insertion was a success. If that's not the case, we will say that we have a failure and we couldn't really add the element that we have pointed to by the first iterator we have in our STD pair that was returned from our insert method here. Hopefully this is making some sense. Let's pass this through our compiler, and the build is good, so we can clear and run Rooster. We're going to see that we could insert a 14 because it is a duplicate, so we're not going to have it inserted here. But if we change our code to insert a 20, let's do that. We're going to comment out the 14, and I think the separator here should really be in front. Let's grab the entire line and put that in front here. I think this is going to be much better. So we are inserting in 20. This is not a duplicate. The insertion is going to be a success, and we will see this message here printed out on the console. Let's pass this through our compiler. The build is going to be good, so we can clear and run Rooster, and we are going to see that the insertion is a success, and we have 20 inserted in our collection, and this is really cool. Now, it is also possible to in-place data in our collection, and this is going to build data in place using our constructors. We are going to be using our numbers collection. We're going to print it out, and then we're going to in-place a 421. This is going to succeed because this is not a duplicate. But if we try and put in a 13, for example, this is going to be a failure. Let's try and do that. So we're going to pass this through our compiler. The build is going to be good, so we can clear and run Rooster. We will see that we have added 421 in our collection. If we comment out the line that is adding 13 and comment out the line that is adding 421 and build again, we will see that this is going to be a failure, and we will grab that in our if check here. This is really cool. So let's clear and run Rooster. We see that our in place is a failure. This is not going to work because we don't support duplicates in our STD set collection. We also have the possibility to erase elements, and the way we do that here is a simple example. We can print our collection, then we're going to hunt for the iterator pointing to the element that we want to remove. If we found the element, we're going to say that. If we don't find it, we're going to say that right here. And then we're going to erase using our iterator, and the element is going to go away. We can see that right here by printing our collection. Let's pass this through our compiler. The build is going to be good, so we can clear and run Rooster here, and we're going to see that the data is going to show up. We're going to have a 13n, but after we find it, we're going to erase it, and we're going to see that 13 is gone. This is how we can use our erase method on an STD set container. This is going to work really well. We also have the ability to swap elements up in collections. So here we have two collections. One is going to be other numbers, the other is going to be numbers. We are going to print them out, swap them up, and then print them again, and we're going to see that they are going to exchange data. This is nothing surprising to you now. We have seen this like a gazillion times. So the build is good. We can clear and run Rooster, and before the swap, we're going to have the data here, and after the swap, we're going to see that the collections are going to exchange data. This is going to work really well. Now, the last thing I want you to see is that we have the flexibility to change which callback is used by the compiler to decide which element is greater than other elements. Let's comment out our STD set we have down below because I don't want this to confuse us. So what we're going to do is go on top and do what we do by default by specifying an STD set without putting in an explicit callback. This is going to use the stdless functor by default, and it is going to order elements from the smallest to the largest. This is what we have seen before. If we loop through our container using a range-based for loop, you're going to see that elements are going to be ordered in increasing order. Let's pass this through our compiler. The build is going to be good as you see here, so let's go down and clear and run Rooster. We're going to see that if we change the comparator, things are going to be ordered in ascending order, but we have the flexibility to specify our own callback, and one option is to use a built-in functor like stdless. We can pass this as a second template argument to our std set object here, and the compiler is going to use this to order elements. stdless is going to order things from smallest to greatest, so we're going to get the same output, but now we are using a callback that we specified ourselves, and this happens to be a built-in functor. I want you to know this. Let's pass this through our compiler. The build is going to be good as you see here, so we can clear and run Rooster. We're going to see that things are going to be ordered in ascending order, but now that we have the possibility to pass our own functor, we can even pass a functor that is different than the one that we use by default. So for example, we can pass in std greater, and what this is going to do is order things in descending order. So 16 is going to come first, after that we will get 15, and we will be able to order our things in our std set exactly like we want. Let's pass this through our compiler and confirm this. So the build is good. We can clear and run Rooster. You're going to see that the order is reversed now because of our comparator that we are using here, which is a built-in functor. We also have the ability to specify our own callbacks, and these callbacks can come in the form of either functors or regular function pointers. So let's set up a functor, which is going to be int comparator. This is going to overload the function call operator. It is going to compare things using the less than operator. This is nothing new. And down below, we will set up a regular function, which is going to be comparing using the less than operator. Once we have these in, we can go down in our code and use them. So we can comment out the line that is using our greater functor and use our int comparator, which is a functor. So the compiler is going to pick this up and use it to compare data, and it is going to order things in ascending order because that's what this comparator is doing. It is providing a less than operator. Let's pass this through the compiler to see if this actually works. The build is going to be good, so we can clear and run Rooster. We're going to see that things are going to be ordered in ascending order. Hopefully this is not confusing, but I want you to see that we also have the possibility to pass a function pointer as a callback. And the syntax to do that is a little bit ugly. So we say std set, we specify the type that we store in our set. Then we specify the signature of the function that is going to work as our callback. The function is going to return bool. That's what we have here. And it is going to be a function pointer variable that we pass in here. Then it is going to take two parameters, which are going to be of int type. That's what we are saying here. Then we're going to pass an instance of a function pointer within these two parentheses. Once we use function pointers, we lose the flexibility to initialize with braced initialization like this, but we still have the option to insert data just like we do here, and data is going to show up in our collection, and the compiler is going to order things by using the function pointer that we are passing right here, and this is going to work really well. Let's pass this through our compiler. You're going to see that the build is going to succeed. The build is good. We can clear and run Rooster, and our things are going to be ordered in ascending order using our less than operator that is used in our compare int function pointer. This is really cool. We can comment this out and even use a lambda function. I want you to see that. So let's go down and uncomment our code that is using lambda function. And we have a bunch of squiggly lines, and let's see, the problem has no member named function. I think the problem is that we don't have the functional header included. Let's try and put that in and see if the problem goes away. So let's say include functional. And if we go down, hopefully the squiggly line is going to go away and our code is going to work. And let's go down and find our code. We have the code here. So the squiggly line is gone. And the syntax is again a little bit ugly. We say std set. We specify the type that our std set is going to store. And then we specify that we will pass an std function object as a callback. So once we do this, we specify the return type to be bool for our callback. And the callback is going to take two integers that it is going to compare using the less than operator. That's what we are doing here. So we can pass in this std function as a lambda function here. So our callback is really going to be this entire thing that we have within these two parentheses here. This can be confusing to many people, but this is going to work. Let's do this and really show you this. This is going to be our callback wrapped within this shape here. Hopefully this is making sense. Now this is going to compare using the less than symbol or operator, and if we pass this through our compiler, the build is going to be good as you see. So we can clear and run Rooster, and you're going to see that things are going to be ordered in ascending order, And again, we have the flexibility to really change things. For example, if we go in the body of our Lambda function and change the operator to be greater than, this is going to order things in descending order. Let's try and build and show you that. You can really play with us and make sense of what is happening behind the scenes. Let's clear and run Rooster. You're going to see that things are going to be ordered in descending order, and this is really cool. This is really all I had to share in this lecture, showing you different ways you can work with STD set. I think the feature here to pass your own comparator can be a little bit confusing, so please watch this a couple of times if you think this is confusing. If you still have a problem, you can ask me and I will do the best I can to help you out. For now, I am going to stop here in this lecture. In the next one, we're going to learn about the STD map container. Go ahead and finish up here and meet me there.